Yeah, so hello everyone. Hope you're doing well. So as NumPy series is going on, right? So we have seen how to, what is NumPy, how to install NumPy. NumPy is one library of the Python, right? Mainly it is used to work on that numeric values, right? The name suggests the full form is numerical Python, right? So it is used to perform some operation over the one kind of arrays. So before starting that NumPy, right, we should know what is the arrays and all. So arrays is a one kind of data structurized. It does store data into a sequential orders, right? It does always store data in a sequential order. So we have a different type of array like one-dimensional array, two-dimensional array, and multi-dimensional array, right? Why it is required, why it is needed? Because if we have a bulk of data, right, like for example I have one data, I can go with the one variable, so that time we have a different data types, right? Int, float, boolean, right? That will store one data. If we have a single row data, that time we can go with the vector store data into a single row. Matrix is a store data into a two dimension means it could be in the form of row and column, so that could be row and that could be column. So here we have how many row we have? Two row, and we have a two column. So first row we have two row, two column, right? So first row we have column 1, column 2. So column always count with the horizontally, row always call in the vertically we will count that column. So here 7 8 is a one column completed, 2 and 4 is like a one column, and row is what? 7 2 is a one row, 8 4 is a one row. So whenever we have bulk of data, right, and if you want to store that in a one particular place, that time we use matrix, or I can say arrays actually. Okay, normally what happen, right? If we are going with the single, we can go with a single variable also. That is also one question that can come. But the thing is that here that will store in a different location, different places, right? If we have bulk of data, that time we do perform some operation with that, like I do search that, I do retrieve that, right? I can do n number of operation with them, right? So for that purpose only we do go and use with this array values, right? So that's why we have vector, we have matrix, and we have a tensor as well. Tensor is having multiple two-dimensional array, right? Like that, like you can see here. So it is a multi-dimension. You can go with this command, the tensor. So these are the different type of matrix or the different type of arrays which we can create, right? So tensor flow is a kind of multi-dimensional array, two-dimensional, one-dimensional, and no dimensional, like kind of that single value which we have, right? That is also come under the arrays only. So that all we will understand with some examples and what are the different methods it has. Okay, now let's come to the PyCharm directly. Okay, so here as we have created, like suppose this one. Let me comment that, put into comment section. Okay, so first we have to import, right? Import is required because we are using NumPy, right? So import NumPy as NP. So NP is a short form of NumPy, and here we are using one function like arrays. So as I told you, right, NumPy is a one kind of library. So to perform any operation, right, it has given a lot of functions. So here function, that's why we are calling np.array. It's a predefined function, right? So np.array and 1 2 3. So it is creating a one dimensional array, right? So that is called vector only. So if we will run this code, it is still running, it's a bit slow. So you can see here I am getting that one dimensional array, right? So whenever you have a one dimension, you can go with directly and assign the value like this only. So this is called vector here, which is having only one dimension, right? Other than that, if you want to create a two dimension, then we can go with this way. So here we have to assign that two dimension. Okay, so what we are putting here, we are putting first square bracket, right? So this is a one row, that is a one inside, and that is a second row, right? And these are the column of the first row. So here you can see, right, we have one outer square bracket. outer square bracket is for what? Complete matrix, right? So that is having here in a matrix format, which will be in the row column, right? Here we have a single thing which is a row only, right? There is a vector, one dimension, right? Matrix, here it will be in the matrix form. So if I will display this one here, say M, okay, and let me write this print, so it will give us some space in output. Okay, now let me run this. So you can see here now, first it is giving a single dimension, right? Now here it is giving a 2 dimension, right? So if you know the matrix, right, matrix also will perform operation in the 2 dimension, which could be row and column. So here 1 2 3 is a one row, 4 5 6 is a one row, and what is a column? So vertically whatever we are seeing, these are the column only, like 1 comma 4 is the first column, right? And 2 comma 5 is the second column, 3 comma 6 is the third column. So that way we do understand. So if you're having a this way, that means it is creating that matrix only, right? Matrix means we have a 2 dimension. A vector means we have like 1 dimension. So that way we can understand. Okay. And third we have like suppose transient as well. So let's tensor as well here. So what we are doing here in this tensor, we are creating a multiple. So you can see here it is a 1 dimension. So inside that we have like one outer, right? That means here it is a one matrix. It is a like second matrix, right? Inside this we have a 2 matrix here, right? One matrix is that, one matrix that, which is a 2 by 2, right? And that is also present under the outer matrix. That means here we have a like one outer block, and the outer block having a 2 dimension matrix, 2 matrix, right? That is called like tensor. That type of arrays comes under the multi-dimension array, right? That comes under the multi-dimension array. So that way it will perform the operation, and here we can directly say np.array. So whichever element we are passing, and according to that it will create that array. It could be 1 dimension, it could be 2 dimension, it could be multi-dimension. So multi-dimension array in NumPy, it is called tensor only, right? So if you will display here like print of t, right, what does it do? So see here it is creating a multi-dimension array, right? So here it is going to create a first 2 dimension, it is a 1 matrix, right? Then it is a second matrix, and these both are part of this one outer matrix, right? So that's why we can understand. You can see it with the square bracket only. Here I have only 2 square brackets. So 2 square bracket means one is under the first row and second row, something like that. But here you can see that one more extra bracket is there, right? So that is a part of one matrix, and that is also part of one matrix, and they all are the part of an outer block, right? So that way we can store that multi-dimension as well. So this is a multi-dimension, right? This is example of multi-dimension, this is example of 2 dimension, it is an example of 1 dimension. So whichever dimension is required, we can create using the NumPy function using array, right? Now let's understand, we'll perform some operation over this array like searching, sorting, right? How we do that? So we have a different method of it, right? Suppose if you want to convert this in a specific type, right? Like for example, here I am creating a one array, right? Array 1 2 3. So what is the different type I want? By default it will take that element whichever you are adding, that type only. If you are adding this 1 2 3, that means we know 1 2 3 is like integer only. 1.0 2.0 3.0 comes under the float only, right? True false will come in the boolean only. But if you want to make it in a specific type, that also we can use a specific type. So this time this will create a one array, 1 dimension array, but all the element you can see here it is coming 1 2 3, right? But if you are going with the float, right, that time it will come with 1.0 2.0 3.0, right? Let me run this. So you can see here, I think I did not display them. So let me store in a one particular variable like x equal to, and let me store them. Print with this x. Okay, so in this scenario what happened? You can see it is starting with the point 1.2 3 point something like that, right? Here you can see that there is a no point actually here, but here it is giving the point. That is a float type. I can give here like suppose boolean type as well, right? So boolean, we know that could be either true or false, So if you'll go here, right, you can see it is coming true, because here we have a number 1 2 3. So all the non-negative, all the positive numbers, right, other than 0, all the positive number other than 0 which is greater than 0, they all comes under the true category only, right? If they are having a suppose 0, so 0 comes under the false category. 0 comes under the false category. So this time you can see here it is coming as a false only. So that way whatever element you are adding, and if you want a specific type of it, right, that will also be do specified, right? Like we have a complex as well, right? Let me put the complex. So complex way will having imaginary part as well, right? So you can see here 1 plus 0 j, 2 plus 0 j, 3 plus 0 j, right? So that way it will store with all the different data type. If you want to create one arrays with a specific type, that also we can do it, right? We have to use here d type. That's it. Okay, so let me rough this because it is not we have already used it, right? Now let's understand to create some array with a specific type, like for example here. So one way we have seen, that is creating array, and here we have one more way, like for example arrange. What does it mean? It will arrange one element. So here I can go with this, use with a equal to suppose np.arrange, right? Okay, so let me go with this only, arrange with reshape. So normal what happen, right? Let's say what does it do? So here it is saying okay, arranging the element with the 10 only, right? And let me display this, print of a. See what does it give? So it is giving me all the elements arranging from 0 to 9 only. So by default arrange is whatever element we are passing inside it, right? It is creating a one kind of array of it, right? It is creating a one array of it, right? And starting from the 0 onwards, 0 to all the positive number till that number, right? Now here it is creating the single dimensional, right? If you want to make it in 2 dimension, so that time we have to use reshape. What we have to use? A reshape. And here we can use suppose 2 column 3. What does it mean? So here it is saying that 2 row and 3 column, 2 row and 3 column. So how many element we have? Like 10 element we have, right? So that way we can shape them. So 3 multiply 2. So here it will go 3 multiply 2. That means that could be 6 element only, right? So that way it will assign. So here I can give 9, suppose here that should be 9. Okay, so 0 to 8 it will take, and here I am giving number that could be 9 element, right? So 3 comma 3, suppose 3 comma 3. So what first is specifying? That is specifying number of row, and second is specifying number of columns, right? So whenever you are reshaping is there, that means if you want to create that in multi-dimension format, right? So that time it does create this in multi-dimension format, 0 1 2 3 4 6 7 8, right? So that means we have like 3 rows and 3 columns. So vertical is comes under the column and horizontal comes under the row only, right? So that way we can reshape them. So that is a reshape function we have. Okay, so radiant also is one function. Okay, let's look on this as well. So what it is doing here, np.random.radiant, not radiant, randant. Okay, so it is a create the one random number. So what it is saying here, okay, a randant, what does it take? It is taking 3 argument. First it is a starting values, and second one is a ending value. So it is starting from the one ending with the 100, and what is the total number of capacity of it? That could be 24. That means it will generate a 24 number from 1 to 100, right? Please understand what is the 24 is. 24 is a capacity. That means it will generate a number from, see here, low, high and size. So that means 24 number it will generate. That could be random number from 1 to 100, and here it is going to reshape as well, 6 comma 4. 6 comma 4 means 6 will be row and 4 will be the column. So it will having a 6 row and every row will having a 4 column. So 6 multiply 4, that could be 24. So that way it will create. So we are having a different way of creating the different type of arrays. So mainly NumPy is used to perform operation over the numbers, right? Using the matrix form, array form, whichever it is there, right? So see here now. Yeah, now it took some time because it has generated some number, right? So randomly it is started from anywhere. So you can see here how many rows we have: 1, 2, 3, 4, 5, right? 6 row we have. How many column we have? 1, 2, 3, 4. 4 column we have. So number you can count here is started from 1 to 100 only, right? So range will not be other than the 1 to 100. And what is the total capacity of it? That means it is a 24 only. So in 24 we have a like how many number of rows and how many number of column. So 24 number has generated here. So that way this randint work, randint function. So we can use with np.random.randint, right? Hope you understood that argument of everyone and what is the meaning of this, right? So reshape means we are creating a what is different type, right? And if I will not use reshape, that time it will create a single dimension only, right? Let's me I don't have a reshape, that time it will generate the single dimension only, there is no dimension on it, right? So it will generate the number from 1 to 100 will having like 24 capacity, right? So but that time there will not be any dimension. So reshape is only used for if you want to make it a some matrix form or tensor form. Okay, other than that, let's go and understand some more use of it. Okay, and we have, yeah, let's say understand with the sorting. Yeah, so that is also one use of np.ones, np.0. So that means what is happening here with this ones and zero function, let's use that as well. So what we are doing here, it is creating a function of 1 zeros. That means here we are saying that it will be creating a one matrix of 2 by 2 which will be having all ones only, and here it is creating that zeros only. So here we are creating that arrays. So here let me display that x, let's keep this and let's keep y on it, okay, and y, and here I can display simply print of x and print of y. So you can see here it is creating one array of 1 1 only, it is creating one array of 0 0 only. So that way ones and 0 we do use. Where if you want to create a one array of ones, we can directly use np.ones. If you want to create zeros, you can directly use zeros for it, right? So that way it will work. Okay, if you want to perform any sorting, so let's do perform sorting only. So sorting, we know that ascending order or descending order, right? Now let me rub this. You can practice them, okay? It is already there, the code in the comment section only. So here actually we are running that code in different way, right? So that's why I'm just roughing it from here. So sorting is what? So here it is creating one array actually, okay, randint. So what does it do? It will create that one array of starting the size 1, at end will be 100, and 15 it will be take a gap of it, right? So that time what happened, right? Here inside this a what happened, right? It will create a one dimension array directly, which will having a total 15 element, and starting from the 1 and ending will 100, right? Then happen here what? np.random.randint, right? That time also it is reshaping it. So this time it is reshaping it 6, 4. That means here it is creating the 2-dimensional like in a matrix format. So here it will be in the vector format, here it will be in a matrix format, right? Now what we are doing here, we are doing sorting. So sorting we can do with the many ways here. See how much it is easy to perform sorting in NumPy. If you are not using this NumPy, right, without that if you want to perform, that will take a lot of logics actually. It will take a lot of logics to sort on the column wise, right, or natural sorting or reverse order sorting. But here it is too much easy, right? We don't have to do a lot of coding on it, right? So here np.sort, what is doing? It is sorting b axis 0. So axis 0 means column wise sorting. So it is doing column wise sorting. Here it is sorting with ascending order, right? So as we have discussed in Python, that array is starting from 0 as well as from the minus as well, right? So minus means it is from reverse order. If you did not, please watch the previous recording where I have explained that array will having a minus index as well. So minus is nothing like a reverse order. So here it is starting from the bottom to up, and it will reverse that particular element, right? So it is reverse sorting, and it is a natural sorting, which is ascending order natural sorting. So it is starting with the normal sort only. So here it is creating a one array, right, which is a vector. Here it is creating array in the form of a matrix. Here it is sorting it, axis 0, column wise sorting, and here it is sorting, reverse sorting. Here it is sorting with the natural sorting, right. Now let me run this. So you can see here, first it is creating a single vector having a 15 element only and starting from 1 to 100, right. And second we have a like 1 to 100, but it is having a matrix forms. We have given the reshape, right, 6, 4. So that time it is creating the one array which is having a 6 rows and 4 columns, right. So that part is over here, 6 rows and 4 columns. After that, what we are doing, it is displaying the sorting, right. So print is displaying the sorting, column wise sorting. So it is sorting on the column wise. You can see here 23 we have first, right, then 54 we have, then 61. So all the column it is sorting. So first it will take all the columns value and it will sort it, and that it will take the second column and sort it, third column sorted. You can see it is sorting on the column wise, right. After that it is sorting in reverse order. So in the reverse order it is sorting, right. It is sorting in the reverse order only, right. So we are sorting A only. So A is having a vector, so that's why it is giving like that. If I will sort here like B, that time it will sort complete matrix, right. So that way we are passing here. So it is sorting what, A only. So we are passing here A is having a this one, right. So that way it will sort, and here it is sorting in the natural order. So here it is sorting with element in the row to column wise, around 23, 34, 64, 92, something like that. Clear it. So that way we can perform the sorting accordingly. Okay, sorting is a one function which we can use. Okay, other than that we can use this append method as well. What append does? Append does add the new element on it. Okay, what does it means? Let me explain that as well. So here what we are doing, we are having a one not take it. Okay, we are having a one arrays which is creating 1 to 100 and having a size 15. If you want to add some element on it, right, so what happen, right, the X it will create, that will having a 15 element on it, right, but here it will add one more element which is a 200 on it, right. So it will add the 200 on it, so that way it will perform the operation. So if you want to display it, I will store that into a by, and here I can display this print only. So whenever you want to see the result, you have to perform the print only. So you can print both X and Y. So X will not having a 200 and Y will having a 200. So X, you can see here there is no 200 on it, right, but in a Y we have a like 200 as well, right. So that way it does store the element. So np.append whichever X which will having a one more extra element on it, right. So that way it will perform append. Other than append, we have a like concatenate as well, okay, unique as well, okay. So we have one more example with append, okay, and we have one unique example. So unique, what it is doing, it is just making the unique value. If you are having a duplicate values, right, like for example here we have a 2 to 2 repeated 3 times, right, 33 repeated 2 times. So that means it will give a single 2 and it will give a 133 only, right. It will not give a more than that, right. Same like where, what where does find all the index with the values greater than 50. So here we are comparing with the values, right, let's say 500. So whichever value it will display, that could be greater than 500, like. So here it is generated from 1 to 100, right. So let me give this in between them only. So let me give 80. So it will give me all the numbers which could be greater than 80, right. And here also np.where, what happen, right, it will give me all the number which is greater than 50 and convert into a 0 actually. So what it is doing here, all the number which is greater than 50, so where will take one condition and according to that it will give me a result. So it will find the index of it, not element. Please understand index. Index means what, that could be 0, 1, 2, 3, 4, 5 something which we have, right, that will give here. So let me make it like a 2 dimension, okay, and here I'm going to use reshape, okay, and here I'm going to write, it's a 15, right. So 3,5, let's say 3,5 or 5,3, okay, let's say 3,5. So what does it do here? It will create the one array. So let me run this, okay, go to there and let me run this, so you will get more understanding of it, okay. So what we are doing here, we have a like one rendent. It is taking from 1 to 100, size will be 15, and it is creating a one matrix of it 3 to 5. Now what we are doing, we are saying please give me index of which is element greater than 18, right? Let me run this now. So see here, it is creating a two-dimension array, right? That is a two-dimension array. Now what it is saying that give me index only here, right? So in the x it will having a two-dimension array which is creating, but in the y what happened, right? I want to know the index. So we are always give an index only those element which is a greater than 80. So you can see here whose number is greater than 80. So here 80 is 83. So here it is giving the index is like for them 0, right? So here 98 giving the 98 index. So it is giving the index 98. 98 index is what? 98 index. So that way you can see here 1 2 0 1 2, right? 0 0 1 1 1, right? So that way it is finding the index of every particular elements on it, right? And here what we are doing, we are converting this x greater than 15 0 to x. So that means whichever element is greater than 50, right, that will convert into a 0 greater than 50, right? So you can see here 83 is converted 0, 73 converted 0, 59 converted 0. So whichever element is greater than 50, that will convert it into a 0 only. Like that, it is having n number of functions, right? N number of functions we have which can be used for many purpose, right? So here we have seen the basic understanding, basic operation, and we have seen that some different methods of it, like sorting, creating, okay, and finding element, appending, right? So that is about in this particular session. Thanks for watching, guys. Take care. Bye bye.